Hello, my name is Eduardo Torreblanca, and today I will present the outcomes of my professional internship at ASDEA in Pescara, Italy. My experience is centered on the high-fidelity numerical validation of the industrial structures, where I had the opportunity to bridge the gap between theoretical seismic engineering and practical solutions. In the following slides, I will guide you through the technical challenge I faced and my professional growth. ASDEA is a primer consultancy firm that bridges the gap between advanced theoretical research and practical civil engineering, specializing in high-fidelity numerical simulation and structural design. The organization is globally recognized for its software development capabilities, particularly for creating STKO, an advanced graphical interface for nonlinear finite element analysis within the OpenSys framework. By integrating a team of PhD researchers with the international standards, the firm delivers sophisticated engineering solutions on a global scale. The most difficult challenge I encountered during my internship was the structural engineering and computational modeling of the Capannone Separato Solido project, located in northern Italy. This task was particularly demanding not only due to the inherent complexity of the structural design itself, because also it required the rapid mastery of Midas Gen, a specialized FAA software I had not previously utilized. The team entrusted me with a substantial technical independence, requiring the application of my own engineering criteria to steer the project through code-compliant and effective solutions. The problem was the structure initial blueprints yielded a natural period of 1.62 seconds, an excessively high value for this project type. Left unaddressed, this would result in severe displacement issues within the roofing system during a seismic activity. After verifying the model parameters to ensure numerical accuracy, I focused the investigation on the analysis of the structural load paths. As illustrated in the diagram, when subject to the design seismic spectra, the bending moments of the roof beams were not being effectively transmitted to the columns. This failure in the moment frame continuity prevented the mobilization of additional mass and the necessary increase in stiffness for the primary vibration mode. To address the stiffness deficit, I evaluate three distinct engineering strategies. Initially, I attempt to modify the beam-to-column connectivity by implementing a moment-resisting frame behavior through a rigid link in the software. Although this reduced the natural period from 1.62 to 0.84 seconds, this was unacceptable. In coordination with senior engineering, I undertook the structural modification of the main system. Based on the analysis of the firm's historical project data, I determined that stiffening the critical seismic direction was the most effective course of action. My first solution involved extending the reinforced concrete wall and integrated a reinforced concrete column coupled with a channel steel beam. This configuration was specifically designed to enhance moment transmission along the y-axis, as demonstrated in the top right simulation. This reduced the natural period to 0.67 seconds. As a secondary indirect stiffness strategy, I engineered a bracing system beneath the roof rafters by optimizing the existing double-angle profiles and introducing new truss members. I achieved a more efficient redistribution of internal stresses. This modification effectively increased the modal mass participation and successfully reduced the natural period to compliant levels, resulting in the optimized dynamic response shown in the bottom right simulation. This reduced the natural period to 0.62 seconds. Beyond the mastery of advanced FAA tools like Midas Gen and STKO, I learned the importance of regulatory compliance and structural constructability. Knowing that the designs I validate soon transition from model to physical construction in Italy provides me a profound sense of responsibility and professional fulfillment. I'm deeply grateful to the team at ASDEA for their mentorship. Thank you for your attention.